There are 6 classic orbital elements. Today I'll show you what those look like using this fun little model and a hair tie. We'll pretend that this shuttle model is a satellite in orbit. The first orbital element is the semi-major axis. It's a math term to describe half the length of an ellipse, because Johannes Kepler discovered that all orbits are ellipses, although some are more circular than others. The second orbital element is the eccentricity, that describes how elliptical it is from perfectly circular to extremely elliptical. The third orbital element is the inclination. It describes how tilted the orbit is with respect to the equator. It's measured as the angle between when the satellite passes the ascending node going up past the equator and the angle from the equator itself. So this angle right here. The fourth orbital element is the right ascension of the ascending node, or RAN. This is a measure of how much the orbit is twisted around the planetary poles. It's measured from the first point of Aries, which is an astronomically agreed upon arbitrary starting point, to the ascending node, like so. So from here to spacecraft motion, starting here. The fifth element is the argument of Perigee. This is a measure of how spun around the orbit is. It is measured from the RAN to Perigee, which is the point in the orbit when it is closest to the Earth. So right here, and this is Perigee. The final element is the true anomaly. This tells us where in its orbit the satellite is at any specific time. With those 6 elements, you know what your orbit looks like and where your satellite is. Let's make up an example to demonstrate this. We'll start with a semi-major axis of 42,164 kilometers, an eccentricity of 0.01, an inclination of 45 degrees. The RAN is 45 degrees, and the argument of Perigee is also 45 degrees, right over here, and the true anomaly is 90 degrees. So with those all being the case, you know that your satellite is going to be right here, and it's moving in this direction in an orbit that looks like this. This is a simplification, but for a video like this works perfectly.